Hi, Mr. Crane here again. Day before Thanksgiving, and I'm shooting videos in the classroom during my downtime. So we're going to do Electromagnet Lesson 1. This is a tutorial for virtual students or for students that are blended that need that extra support. Maybe you're behind or something and you didn't get the full gist of the lesson when we went over it in class. So use this video to help you go back, replay, and rewind, slow it down a little bit so that you understand better. All right, so let's look at it today. Lesson 1, electromagnets. So electromagnets are essentially magnets themselves, but they're called temporary magnets. Magnets that you stick on your refrigerator or you find, at Hobby Lobby or whatever, those are considered permanent magnets. That means they don't turn on or off. Well, an electromagnet is a temporary magnet. You can turn it off by turning the electric current off to it. All right, so electromagnets are created by taking an iron core and taking coils of copper or wire and wrapping it around the core and then connecting that to two terminals on a battery, one wire going to the plus and one wire going to the minus. And when I connect it, the electrons flow around the coil and induce or create. The word induce means to create a current. It induces a magnetic field around the object. And I said in a little iron, maybe a nail or something like that. And the direction of the current, if I use my right hand rule, if I say that, my direction of my current, so my thumb is my direction of my current, the magnetic field will curl around, or the current will flow towards me like this. If it was the other way around, if the current was going that way, then the electric field or the magnetic field would curl around this way. And we'll look at that in a second. So the first question says, draw what you think the Earth's magnetic field looks like. So if I have a compass, I know that a compass points to the north. I'm going to grab a compass real quick. So I know a compass, that way is Fayetteville, where I'm sitting in my classroom right now. That way is Fayetteville, and this compass is pointing, the red end of my needle is pointing that way. So you can see the red. See if I can get you to it. The red end, turn it towards you that way. The red end is facing that way. That is north. And that needle will move as it comes into contact with magnetic fields or excessive amounts of iron, like my cup. I don't know if my cup's probably aluminum. It is. My cup's aluminum. See if my phone affects it at all. Doesn't. See if my screen affects it at all. Doesn't. So there's not much iron around here, not much electric current, but when it comes into contact with like the whiteboard, which has got iron in it, it will actually make that needle move. So Earth's magnetic field, the North Pole where Santa Claus lives, is the geographic north. That means that the location is in the north of where we're at. But magnetically, my North Pole, I know that opposites attract. My North Pole has to point to something that's opposite of itself. So if this is my north end of my magnet in the compass, it must point to a southern end of my Earth magnet. So that means that the geographic North Pole, is actually the South Pole of our magnetic poles. And I'll see if I can show you what I'm talking about. So we'll say we're going to pull up a Google image of an Earth magnet. Earth magnet. Okay. Get rid of this thing here. So Earth magnet. So we have Earth's magnetic field. Here's a great picture of one right here. I'll move my picture so you can see it. So Earth's magnetic field. So if I copy on this, I right click and hit copy. That's what I can put into that image. But if we notice, our Earth's magnetic field is slanted slightly. In Arkansas, it's about, I think it's about 7 degrees, or maybe it's 12 degrees. So to the east, slanted to the east, so our compasses point that direction to magnetic north, which is not actually magnetic north, it's magnetic south. But all of our compasses point to this particular south Earth pole. And on our lesson that we're going to look at today, it says, what do you think the Earth's magnetic field looks like? So, really simply, I just pasted in the picture. That's what it looks like. It doesn't have to be that big. It's a pretty good picture. And I hope you understand what I'm saying about Earth's North Pole, geographic, is actually the Earth's magnet's South Pole, because this north right here, let me let it line up again. This north needle has to point to something that's opposite of itself, which would be a south pole. So in order for it to point to the north, geographic north, it's pointing a south magnetic field, which is what I'm showing in this image right here. All right, let's go on to number 2. Oops. In your explorations of your school and your classroom, where did you find magnetic fields? Now, I have a video of me doing this. If I can go back a little bit. It is, let me see. I'll put that video in this little section. So whenever you need the video lesson for today, it's called Electromagnet Lesson Video Supports, Lesson 1 Video Supports. But let me get caught up. The question said again, let's go back to it real quick. In your exploration of your school and your classroom, where did you find magnetic fields? So I have already created a video for you where I walk around the classroom, and it's called Earth Magnet Class Session 2 parts. So follow me and a student that I had in class several years ago, it's almost graduated now, as we walk around the classroom and investigate magnetic fields around the classroom. And where you see that needle of this compass move, where you see that needle of that compass move as it comes into contact with a magnetic field, just write that object down, and you should be good. But watch that video. I'm giving you everything you need, so I shouldn't hear I don't have magnets, Mr. Crane. I couldn't do this lesson. So you do have the support you need. Just use them. Number 3 says, what were the shapes of the magnetic fields? What do they look like? And how could you tell? Let's go back to this image of Earth magnets. All magnets are going to give this shape. If you notice, if I click on several of these fields, what field is that? That field looks like an oval, doesn't it? So it's an oval around the Earth, regardless of which picture you're looking at. Regardless of what picture you're looking at, that's a great one right there. Showing the same thing we show in the north and the south, and south and the north. Here's another one. So those are that shape that you see right there. List that on this question. All right, number 4. We're on number 4. Were the magnets constant in time? So the term, you know what time is, and constant means the same. So did the fields change, or were they the same? When you investigated them, was your compass sitting there? Was your compass sitting there going, woo, 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 woo? You know, was it spinning around like crazy? And I can recreate that for you. Or was it steady? So I have a magnet here. And that magnet, if you can see it, is found the direction is the south. And that means this end here is the north. So were the fields constant in time? Were they sitting steady where the compass needle was not moving? I mean, it moved for a second when it flipped, or was it doing this? Was it going around, around, and around, and around, and around? around in circles like that. So that would mean they weren't constant in time. They weren't steady. So were they constant in time? Answer that question. What had the strongest magnetic fields, and how did you determine which had the strongest magnetic fields? Look through those things in that video and see when the compass in the video really starts to go haywire really quick. That's going to be a strong magnetic field. It's strong enough to overpower the compass and pull it away from Earth's magnet. So hope that helps you. That's everything that you need to know. Good luck with your assignment, and please don't send me a message saying I couldn't do it, because I just gave you everything you need to complete it.